We're live.
We are. Hello. Welcome.
That's amazing. This is the most punctual I think we've ever been.
Yes.
Actually, so let's kick this off. Hello, people watching on YouTube. Hello, everyone catching up on the podcast. We're a little earlier than scheduled today because at 4 o'clock today, I'm probably going to be in a queue at the passport office, and Mark is probably going to be on his way into London to talk tonight at the London.net user group meetup about JavaScript.
Going to be talking about JavaScript, yes.
Although it's actually I've seen this talk I think twice now, and it is fascinating looking at the like every program. Nobody ever created a programming language like in a vacuum. You look at the evolution of programming as a discipline, I guess, and it started off with put this switch and that switch 1010. And there is a lovely sort of maybe anecdotal story, but I've seen this referred to in a couple of places, that Seymour Cray, who invented the Cray supercomputer, once built a computer that couldn't load anything because it didn't have a bootloader yet. And the bootloader is so the phrase booting. Look at this, we're 3 tangents deep and we're 1 minute into the stream. It's brilliant.
Where does the word boot come from?
Well, there's this the problem with a computer. One of the many problems with a computer is that it has a thing called an operating system. And one of the things the operating system does is it reads things off disks. And the operating system lives on the disk. Hey, Martin, welcome to the stream. And so when you first switch your computer on, the code that lets it read the disk is on the disk. So you need to read the disk in order to get the code that lets you read the disk in order to get the code that lets you read the disk. So which for some reason, and I never quite got this part, is like pulling yourself off the ground by your own bootstraps. Yeah. Which one sort of doesn't make sense because I've never thought of that as being a circular dependency. And also I've owned many pairs of boots and none of them has ever had straps.
It's those little loops that you get at the back of Doc Martens.
Is it? But are those straps? Really?
They are bootstraps.
I'd have called them loops.
I'm pretty sure those are bootstraps, and so anyway, the idea is that getting a computer to start is like hooking your fingers through those and pulling and expecting to lift off the ground.
Yeah, I can go with that. Yeah. So yeah, when you switch your computer on, there's a tiny bit of memory, the BIOS, the basic input-output system, which kind of gives it just enough brain to upgrade its own brain to a slightly better brain, which can load the bit of the disk that loads the bigger brain and so on until you end up with the rather astonishing conclusion that the biggest brain of all is Windows 11. But so Seymour Cray once had a computer which didn't have a bootloader yet, and apparently he programmed the bootloader in Octal in 8-bit machine code using 8 toggle switches and a button. So he'd set them to an 8-bit instruction and then push the button, and it would push that bank of switches on and off true false into the next register. And then when he'd got them all in, he pushed go, and it went, "Hello, I am your supercomputer," which I just think is rather wonderful. So
it sort of reminds me when I was a kid. When I was 9 years old, I got my first computer, and it was a Sinclair ZX81, and it had 1K of RAM. And you couldn't really buy software for it. You could, but my parents wouldn't. But it came with a book which taught you basic programming and had lots of little programs.
Is that basic programming or basic programming?
Both. But one of them was an Etch-a-Sketch.
Yeah.
And my first sort of successful programming achievement was that I got, so it basically did up, down, left, right, and you used 4 keys on the keyboard to do this. And it would draw horizontal, up, X, Y type things. And I modified it so that it used, I can't remember what it actually used, but say QWE, ASD, ZXC, and would do diagonals as well. And then I just like drawing pictures with it. And I could have saved it to tape and pressed record on something and then loaded it every time. But actually, every time I switched this thing on and I wanted to do Etch-a-Sketch, I would just type in all the code. And I'd written my modifications into the book in pen and stuff. And yeah, and this is how computers used to work before we had punch cards and things. It was set the computer up, configure it with the program already installed, and then run it. And then, you know, the ideas of punch cards and tape for storing programs didn't come about until later.
One of the I never had a Spectrum, but my cousin did, and I borrowed it once when I was using it when I was staying with them once, and the Spectrum had keys that they would basically like draw a block of color.
Mm.
Like
Mm.
it served no purpose. There was this row of function keys that if you pressed shift or function or something, they would draw a block of color. And I sat and drew there used to be a cartoon show called Mask, which was amazing. And I sat and I drew the Mask logo on the screen of a Spectrum just by typing one block of color at a time.
Yes.
Which was the most pointless. Like when it was done, it's like, well, it's just on the screen now. Like when you switch it off, it's gone. You can't save it. It's not a program. It's not anything. I couldn't even take a photo of it because I didn't have a camera. And so I did it and I looked at it and then I went, all right. And then I switched it off. And it was so much fun.
So the Spectrum had this great thing called user-defined graphics. And it had data. So one of the basic commands was data, and then you would just put hexadecimal numbers after it. And the characters were 8 by 8. And so 8 bytes, you could define 8 rows of bits, and these were just monochrome black and white characters, but you could make little 8 by 8 characters. And then you could sort of make 4 of these characters that made a larger character, and then you could try and move that around on the screen. And this was like the Spectrum basic alternative way of doing sprites. And I lost hours to that. And I basically learned binary to hexadecimal conversion because I would draw the characters on squared paper and then work out the hexadecimal numbers for each line and then program them in data statements and then use those to define my own graphics and then make little whatever it was run around the screen.
I do think bit manipulation is it's one of the arts that we've lost because it really doesn't matter anymore unless you're doing something very special.
Yes, it's like the size of a Boolean in .NET is actually byte.
Yeah.
I'm like, never mind, we've got... it's one of the things that I talk about when I do my history talks is core memory. Back in the day, the big mainframes, the IBM 704 and things like this, and they had multiple kinds of memory for computers back in the day. So they had drums. They had a magnetic drum that would spin and it would write things onto it, and so that was kind of like your swap file. And when you see those big old machines with all the flashing lights in films with the tapes going backwards and forwards, and the tape is memory. And at one point, one of the things that Turing was working on actually used tubes full of mercury
delay lines.
Set a vibration going in the mercury that would set that bit, which was insane.
Yeah.
But then the first thing when we started sort of moving towards what we got now was core memory. And core memory was a bunch of pins on an integrated circuit. And each pin, they were like needle heads. They had a hole going through them. And then they would run copper wire in 2 directions through these heads. And then they could set each one of them to be on or off based on how much whatever was going through it, whether it was magnetized or not. And these things were made by hand. They were made mostly by women, and they would just sit there with a very thin needle with the wire on the end of it, and they would knit effectively or embroider core memory. And when it first came out, in the same way as, like a 4 terabyte SSD now will cost you an absolute fortune, and if it's new technology, then it's like double it.
Mm.
And so memory in those days cost $1 a bit. So what we think of as a byte of memory would cost $8.
Yeah.
So 1K of memory would cost over $8,000.
And
And
this
then we
is in
wonder
the
why.
days when you could get go to the Nickelodeon, which was a cinema that cost a nickel. So a
Yes,
cinema ticket
exactly.
cost, what is a nickel? 10 cents?
Uh,
I'm not sure. Like
no, it's
the 5. So what's a
5,
dime? A dime is 10.
10.
Yeah.
Yeah,
So
because they had stores called the Five and Dime.
they did. I know that from Mr. Brian Adams, that great
Yes.
chronicler of American folklore.
Yeah, and they
Um,
also say nickel and dime, so I assume 5 and nickel mean the same thing.
that makes a lot of sense. We
It
love it.
does.
Hello, we're
Yes,
inferring American currency from
we
first
are.
principles today. Later, we'll talk about
Um,
the foot pound and how
yes.
it's amazing that they actually went to space using foot pounds as their unit of torque.
But no, on the memory,
Yes.
yes, if you've ever wondered why, throughout the 50s and 60s and quite a lot of the 70s, we stored dates as only 2 characters for the year, it's because those extra 2 characters to specify the century would have cost $16 or something. But no, and, and that they were working with like bytes of memory, although they didn't even have bytes for a long time, because the idea of bytes, if you look at something like the IBM 704, had 36-bit registers. So there was no concept
Yeah.
of 8 bits and bytes and kilobytes and all that sort of thing. But
So
yeah, they had
you're you've heard
bits.
of not Mel Brooks, the guy Fred Brooks. Mel Brooks is
Fred Brooks,
Spaceballs.
the
Fred
mythical man
Brooks,
month
the
dude.
mythical man month, who is a sort of iconic figure in the history and folklore of computer engineering. And his book, The Mythical Man Month, was inspired by working on an operating system for what became the IBM System 360. And one of the decisions that he made early on in that project was to have 8-bit bytes. Because up until then, it's 36-bit words, and they would often, like, they used 6 bits to represent alphanumerics, because 6 bits gave you enough to fit in, that's what, 64 characters. So it was enough to give you all the letters, all the numbers, and some control codes.
Yes.
And he was the person who basically went, maybe 8 would be a better idea. And so sort of created this idea, or formalized the idea, we're going to have an 8-bit register width, 8-bit address width, 8-bit bytes, 8-bit all this. And I think your JavaScript talk is talking about the influence that programming languages have had on each other over the years.
Yeah.
And I think that decision by Brooks to say, no, we're going to go with 8 bits instead of 6, must be one of the most, because the System 360 was kind of influential enough that everything that came after it had to at least acknowledge its existence. It was not a question of compatibility. It was a question of, okay, well, all the companies with lots of money now are buying those. So if we want to do anything with computers that might make us rich, we probably need to do something that Big Corp will be able to work with. Of course, that theory doesn't stand up because EBCDIC character encoding, EBCDIC, which is IBM's alternative to ASCII, because, hey, there's always got to be one, right? That doesn't ring true at all. But yeah.
But because it's weird that having grown up with computers in what I suppose is the post 360 era, it's like eight bits to a byte doesn't feel like a decision that was just arbitrarily made at some point. It feels right, and like that was the only way it could be done. Like we discovered it more than we decided.
So I have a talk about text and character encodings where I talk about designing ASCII and the decisions that had to be made to which gave us. And ASCII is one of those things that I think pretty much everybody just takes for granted now, because there is I'm going to go out on a limb here. I'm going to say there is nobody alive who was programming computers before ASCII was invented. ASCII was 1965. So 19. Actually, no, there will be people.
There will be people.
Roger Waters is old enough to do that, and he's still alive.
Yes, I'm not sure he ever programmed in Ibscadik though.
Well, no, but so yeah, there are people out there who were programming before ASCII was invented. But for the vast majority of folks working today, ASCII was like, that Douglas Adams quote: "Anything invented before you're born is just part of how the world works. Anything invented between the ages of 15 and 30 is new and exciting, and you can probably get a good job in it. And anything invented after you're 30 is against nature, and it's an abomination." Which is absolutely true.
I was 20. No, I was in my 20s when JavaScript was invented, and I did get a job doing it. So yeah, he's right.
Yep.
The thing I think is really interesting about ASCII, though, because we don't use ASCII anymore, although they have just added in .NET 8 a whole bunch of ASCII-related performance optimizations, so char.isASCII letter, char.isASCII digit, and that sort of thing. But so if Fred Brooks hadn't chosen 8 bits, then ASCII would have been different.
Yes.
The original ASCII was 7-bit, and so you had null at 0 and whatever's at 127.
Del.
ASCII
delete. For the good reason that the only way to erase data from paper tape was to punch out all the other holes. So ASCII delete is all the ones, so that if you punch a hole in your paper tape, it punches all of them and it erases it. That's why ASCII del is 127. Yeah.
And then they do extended ASCII, but the way extended ASCII works is horrible, because the second half of that byte can be used for all kinds of different characters depending on what code page you're using, which is where you get like Latin 1 and Latin 2 and whatever else goes in there. But more importantly, what the internet and therefore the world actually runs on in 2024 is UTF-8,
which is
brilliant. UTF-8 is built on top of ASCII, and it is insanely clever, because UTF-8, it essentially goes, right, this is the internet. The vast majority of the stuff that is going to be sent over the internet, and this was certainly true when it was created, Windsurf and all that sort of thing, is going to be ASCII text. It's going to be HTML, CSS, JavaScript, that sort of documents of some description. So if we assume that most of it's going to be that, if we say that any character where the top bit is not set is an ASCII character, and then if the top bit is set, it will be some combination of bytes that means the Unicode character for the poop emoji or whatever it might be. And I know all this from watching Dylan's talks about plain text. But yeah, this is so. The reason UTF-8 is so efficient is because 99% of what is sent as UTF-8 text is in fact ASCII. And the reason Microsoft have just added all these ASCII methods to .NET is because you can very quickly look at a chunk of bytes and say, is that entire chunk of bytes ASCII? And if it is, then you can shortcut a lot of operations without having to worry about whether any of the characters are actually multiple bytes.
Yeah.
And yeah, it's super clever.
So Martin's dropped a comment on why we didn't have ASCII Tipex. So they did, and the Unix patch command takes its name from the practice of using adhesive tape to patch punch cards. To cover over the bits which shouldn't have been punched through, and then potentially punching more of them. So Tipex is no use, because Tipex relies on you reading something visually, which machines don't do. So the closest we got was adhesive tape, which was kind of ASCII Tipex. So
yes, but yeah, and thinking about, because you sent me that link to the Spectrum IE,
the IEEE Spectrum thing about software bloat. Yeah.
And I I was thinking about it. I saw a stat back in the day. I think it was Windows XP. The desktop wallpaper image as a JPEG in Windows XP was bigger than Win.com, which was the Windows executable from the Windows 3.1 days. And we could,
That's what we're talking about.
if we were running the software that I'd been working on in the 90s on today's computers, it would go screamingly fast.
Yeah.
But the computers get faster, and so the people making the software go, "Oh, we can make the software do more things," or fewer things. In the case of Windows 11, if you're coming from Windows 10, it feels like it's not necessarily that it does less things; it's just hidden.
So
The
I
way
had a
to
thing
do
yesterday. I run my main workstation still runs Windows 10. I got Windows 11 on the laptop, but Windows 11 did not like something about my main desktop computer, which is not surprising because it's got 3 graphics cards and 6 monitors and 4 audio cards. And it's like the edge case. Like I file bugs with software and they come back and they're like, what? And I'm like, yeah, if you've got 6 monitors and they're not all in a horizontal line, then your tooltips are aligned to the top of the main monitor, not the top of the highest monitor. And they're like, does anyone do that? I'm like, I do that. Hi,
Yes.
that's my scenario. And they're like, all right. And you ever see those little things on open source? Like this goes all the way when Linus Torvalds first published the Git kernel. He said in the Usenet posting, it'll probably only ever support 80 hard drives because that's all I have. And this sort of lovely tradition of open source only supporting the hardware that the maintainers actually own because they don't have budget to go out and buy devices just to test stuff.
Yeah.
But no, and the other day I was running an application on Windows 10, and as it closed down just for a second, there was this flicker of, you remember the sort of the blue and red, like the Windows XP style Microsoft Office 2003 look and feel? There was
Yeah.
this little flicker of that just as it was closing down. I was like, it's still under there.
Yeah.
Like something that application thinks it's drawing on Windows XP,
Yes.
and something in the Microsoft layer is going, no, you will render like this. I'm like, can we switch it off? Like, why is there not an option to just be like, look, just bump all this stuff back to just let it run the way it wanted to run in the first place?
Possibly the most sort of value per hour that I spent on it in terms of writing software. When I worked for Iris, and we made membership management software, and
Yeah.
it was written in Gupta SQL Windows.
In what?
And we were stuck on an older version of Gupta SQL Windows for some
What
reason.
what is Gupta SQL Windows? Those are 2 things I recognize and a word I've never heard said
Right.
together quickly to make it sound like a thing.
When Windows came along,
Yeah.
the place where I worked, we did Infomix 4GL. We had done ESQLC, now we did Infomix 4GL, and then Windows. It wasn't actually Windows, it was Windows for Workgroups 3.11. And the difference between that and Windows 3.1 was that Windows for Workgroups had WinSock built in, and Microsoft killed a whole bunch of independent, paid-for WinSock implementations.
WinSock is the network socket layer,
network.
like the thing that lets Windows talk to TCP/IP and to NetBEUI, NetBIOS, and basically talk to other computers.
Do you
which
remember
Windows couldn't do. Yes.
Two Cows. So 2 Cows was a place where you would download software. What it actually stood for was the ultimate collection of Windows sockets. And they started out, if you want Windows sockets software, then go to 2 Cows because they've got the ultimate collection of it.
And then it became the ultimate collection of WinSock software, and then it became the ultimate collection of Windows software.
Windows software, yes.
And they just went, let's just relax the acronym a little bit.
It doesn't stand for anything. But anyway, so we had to switch over and start building software for Windows. And so my company said, check out the available options and we will choose one. And the available options at the time were Visual Basic 3
Yep.
Visual Basic 3 didn't have database access.
Yep.
Not in the box. They didn't have ODBC. They didn't have DAO, any
Yep.
of those things. So we couldn't use that because we needed databases. So then there was Power Builder and Gupta SQL Windows.
Mm.
And I tried both of them, and I liked Gupta SQL Windows better. It was easier to learn. It was easier to build software with. And at the time, it was, insanely good. And so, yes, I said, let's switch to this one. And then I did some consulting and I did some training, and I went to a company where we'd done Infomix work, and they wanted to build a Windows version of their software. And I said, okay, you can use this. And so they did, and we had it running on Windows 95. We had it running on Windows 3.1.1. Then we had it on 95. Then we had it on 98. Then we had it on 2000. And then XP came out in 2002.
Yeah.
And XP was the first one since Windows 95 that changed the look and feel. And it went to that kind of flat and light blue, slightly rounded outlines on text boxes and all that sort of thing. Completely different look and feel. And Gupta SQL Windows did not automatically adapt to that, which was vexing. It wasn't calling into, and there's a very simple set of system calls in Windows for draw a text box, draw a button, draw this, that, the other, draw a group box. And so I wrote a C++ library.
Oh, Mark has temporarily. Oh, there you are. Hello.
Message. Hello, you still there?
Yes.
Good. Excellent.
Technical difficulties. Hello.
Captured the paint message for any of the Gupta controls and replaced them with the Windows Paint thing, and it basically made the entire application look like a Windows XP application. And then I had a nervous breakdown and left the company. But I found out later that when Windows 7 came along, it continued to work. So it continued to make what underneath was looking like a Windows 95 application look like a Windows 7 application. And I guess it still works to this day.
Prior to that, did Gupta SQL Windows, did they have a team of engineers who were like, we need a function that draws a button? And they sat down and figured out what a button looked like and then wrote their own code that would draw a gray button at just the right size with the right font so that it looked like Windows, but it wasn't Windows.
I think so.
Yeah.
Probably. What I can't be sure of is whether those Windows API calls that I was making actually existed prior to Windows XP. It's possible that they were new. And it's possible that they only kicked in if you were running XP. I think we might have had a WinVer check in there. But yes, so when you see software that occasionally glitches and looks like it was running on Windows 98, it's because it's just done a hack, and underneath it is still Windows 98, and it's just sort of layering the current version of the operating system
so there is
on top of whatever. It's like a web page when it hasn't downloaded the CSS.
So if you want to see the oldest thing that still exists, I'm going to just share my screen here for a second and see, can I scrap, and I'm going to present that one. Yes, share screen. What screen do I want to share? Let's share that screen. There we go. I know. So if you go into, this is on Windows 10, and if you go into the control panel, there is a thing in the control panel somewhere about ODBC data sources. Where is it gone?
Oh, yes.
Set up ODBC data sources, 32-bit. And that brings up this. And if you go to File DSN and you click Add, and you say driver so I love the fact that this is all the different languages they have. But if I say next driver and then click browse, you get, they've changed it. This thing used to be the oldest piece of Windows code that you could still find anywhere, because it brought up the old Windows 3.1 dialog browser
Oh,
as
wow.
recently as like Windows 7 or probably Windows 8 as well. And it was just this, like, we don't need to change that because, file system DSNs is such an deprecated piece of technology in the age of web APIs and stuff, that anyone who's looking for it is going to know what to do with the old Windows 3.1 dialog. And anybody who isn't looking for it isn't going to find it, so it kind of doesn't matter.
It's just brought back so many horrible memories of trying to set up DSNs on people's machines so that they could see databases. And, just horrible. But no, because that article about Bloat, and I'm going to share my screen quickly because I just love this. Share screen. No, we want a window. We want that window. We're going to share that. There we go. Yes, and it reminded me of this GIF that did the rounds a few years ago, of like showing the distortion of space and the heaviest objects in the universe, and it's got like the sun, which makes a little dent, and then a neutron star, which makes a deep dent, and then a black hole, which makes a really deep dent, and then node modules, which goes off the bottom of the GIF. And it's, we talk about software bloat in terms of, I downloaded Call of Duty and it was 67 gigabytes, and now I can't install anything else on my Xbox or whatever. But to a certain extent, it's not our fault as developers, because we've been given all these package managers and we've been told, use these package managers and share your algorithms and your solutions to problems and everything else. And so we do. And we pull in sort of something from node modules, and it pulls in 15 others, and then they pull in 15 others each, and it just exponentially grows and grows and grows.
So we'll come back to that in a second. But
and then we ship it.
Martin's put a comment in, presumably talking about file system DSNs, about is this like people who make rooms for people with dementia match the rooms from when they were younger to make them feel more comfortable? Which I suspect the answer is no. I don't think that's a valid comparison, but it is a nice little anecdote. This is in the Netherlands. It's quite common in like retirement homes that when people are moved into protective housing towards the end of their life, they will paint the front door of their room to match the door of the house they used to live in, so they recognize it and they know which one is theirs. Yes. And there's another thing that I read about, which is a sort of retirement care home where they have a bus stop, a little piece of road, and there's no bus. Because generally when people wander off, what they'll do is they'll wander to the bus stop and wait for the bus. And then the staff will just, like, every 20 minutes, they'll go past the bus stop and be like, hello, yeah, I don't think the bus is coming. Shall we go back inside? And it's just a sort of very, very gentle way of giving them some familiarity and everything in what must be a pretty frightening and traumatic set of circumstances.
That's rather lovely.
Yeah, I think that's great. So
I'm expecting to get dementia at some point in the next 15 years, and it's nice to think that people will be doing things like that.
Just remember to get a photo of your front door so we know what to paint the room like. So no, we're talking about going back to talking about.
I mean, you're just stuff. Fill it with bases.
This to me is absolutely. So there's the IEEE article that we linked to a little while ago. I'll just drop that back up on the screen there. The author of that article has created a piece of software it's basically like a imager, or like a website where you can share images. You can paste images and upload them and everything, which is designed to use minimal kind of external code. It's 1,600 lines plus a handful of dependencies. And so you can actually read the whole thing in a day.
Yeah.
And this is a thing that I've always thought, there is a massive difference, because one of the problems I think we have with things like, node modules or NPM or, Ruby or NuGet or whatever, is the lack of distinction between, so to me, there are modules, there are libraries, and there are frameworks.
Mm-hmm.
And a module is a piece of code that does one job. So if you have a uncompressed map of RGB values and you need to write that or you need to turn that into a PNG, to me, that is a module. That is not something anyone should ever be re-implementing for any reason. We've solved that problem. You need to do that. You need to do a zip or 7-zip or tar encoding, all of these use cases. How do I render a PDF? Well, we've fixed that. It's done. That's a module. And then the libraries are kind of companies going, well, if we, we'll do bitmap and we'll do PNG and we'll do JPEG and we'll do TIFF encoding and we'll do all these kinds of things and pack all those into this library, and then people can use our library and pay for it or not, depending on the licensing model. And one of the things that is referenced in the IEEE article we're talking about was a vulnerability in iOS, because if you sent someone an iMessage with a PDF attached to it, it would try to show you a preview of the first page of the PDF on your notification screen, which is the thing you get before you've even unlocked your phone.
Yes.
And the library they use to render PDFs had a vulnerability because PDFs can have code execution, because the PDF format includes scripting capabilities.
Yes.
And so there was this vulnerability that if you sent someone an iMessage with a PDF, you could get control of their phone without them having to touch it. Which is the worst thing you can possibly imagine. And, it comes down to, why would anybody like that? That's the kind of thing they throw in, because they're like, well, we got this library and it'll do PDFs. We might as well enable that. And, I cannot believe that the company who built a phone without copy and paste because Steve Jobs didn't want it or didn't think it was important in version 1, said, oh, no, this is absolutely a key requirement. You have to show a preview of the first page of the PDF if somebody else with an iPhone sends you a PDF as an iMessage. It's not a requirement. It's might as well throw this in for free because it's here. But then, so to me, the modules solve one problem. They do it well. And to me, a good module is one that if the licensing changes, or for whatever reason you decide you no longer want to take a dependency on that module, you understand exactly what you need to do to replace it. The inputs, the outputs are clearly defined. It lives over here, and you can delete it from your project and it will fail to compile. And you're like, right, I need to implement that interface here, bang, done. And libraries is just a bunch of those. But then, frameworks kind of get to the point where, imagine trying to remove MVC from an MVC project, or remove React from a React project. And, frameworks get to the point where it's like, oh, no, this this will inform how you make design decisions about the entire application you are building. This ain't coming out. No. This is the foundation that you're building stuff on top of. And we've lost that distinction, I think, to a very great extent, that it is all too easy to install. You need something to compress PDFs, and you install a library that doesn't. Suddenly you've got all this other stuff which you don't really need. And you end up with millions of lines of code. I had a talk a while ago about one of the things I mentioned was create React app. And if you type create React app in an empty folder, you get 1.5 million lines of code in that folder, which is mostly for Hello World. And that is, mostly development time dependencies. It's not code you're actually going to ship to your end users, but it's 1.5 million lines of code to not do anything yet. And that's where you start from. And no one's ever going to actually read or review or audit all that stuff. And
talking about modules, so case in point, I worked for a US company who did legal filings over the internet. They were basically homogenizing API for various courts and districts and all that sort of thing. And people would upload Word documents, or in some cases, LibreOffice, whatever it's ODF and that sort of thing. The open document format. And we had to, whatever they uploaded, we had to convert it to a PDF and then store it in Azure Blob Storage. And there are multiple PDF libraries for .NET, and all of them are paid for. And we tried all of them, and none of them would reliably convert every document format to PDF. in a way that it looked like it had in the original editor. But two of them, between them, could do all of them.
Yeah.
And so we were doing microservices. And so the thing that converted a document to a PDF was a microservice, and it just ran in the background and uploaded the PDF. And so we had two of these microservices running, one with one of the PDF libraries and one with the other PDF library. And they were both listening on the thing, and they basically, when they got a message saying this needs changing to a PDF, they would look and say, is it one of the formats that I can do? And if it was, they would do it, and if it wasn't, they would just ignore it and mark the message as completed. And so if either of those libraries had at any point got their act together and been able to do all of them, we could just have switched. We wouldn't have had to change any code. We could just have turned one of those microservices off, and the other one would have known that it could do what it needed to do. And that's modularity. That's kind of the point of microservices, is being able to change the behavior of an overall system just by adding or taking out a service.
I'm going to argue with you on that point. That is not the point of microservices. That's the point of building software well.
Well, yes, but it's one of the advantages of microservices is you can do that kind of thing.
Yes, it is possible to get exactly the same advantage. So to me, microservices is one of those terms that became very, very popular, and a lot of people went, "Oh, we need to do that because they're doing that." And I sort of stand by the conviction that microservices only make sense if each microservice has a team, and that's it. And if you are a team of 3 people running 8 microservices, you are doing it wrong, because you don't have 8 people who can maintain 8 microservices, and each of those people can deploy their microservice whenever they need to, and so decouple themselves from, microservices was a reaction to monolithic software where you had to have a 3-month code freeze before you went live, because you had 25 different teams, all of whom had to fix all their bugs without stepping on each other's toes. And
so I'll be honest and say that particular instance, it was just me, and there was the main API, there were the 2 background microservices that did PDF conversion. There was one that there was 6 or 7 independently deployed services on Service Fabric as well. So, it wasn't fun deploying them. And it was probably the job where I learned not to do that. And I think we collapsed some of them back into the main thing, but we did leave the PDF conversion out simply because of that. There were 2 PDF things, and they all use the same names for everything. And so working with 2 libraries that do the same job in the same assembly is actually quite challenging.
So Martin's just commented, microservice solved a people communication issue because communicating is hard, so you get to keep other people at arm's length, which is a sort of blend, I think, of cynicism and truth, because communication is expensive. They have done studies, and this is Fred Brooks again, isn't it? As you add people to a team, the amount of productivity scales, it's linear, but the communication overhead scales exponentially.
Yes.
If you add 1 person to a 5-person team, you have 20% more theoretical throughput, but something like 500% more conversation and communication overhead to make sure everyone else knows what everyone else is doing. But there are absolutely companies. I love companies. So Stripe here is an example I'm just going to pick on because I was working on them last week. I've built many systems that use Stripe, and I've never had to talk to them, because they are very, very good at saying, here is a platform, this is how it works, here is the documentation, and it actually tells you everything you need to know, and the system does what the documentation says it does. And so to me, that's an external service that I find very, very easy to integrate with. There are other companies, who I'm not going to name and shame, where you go through their docs and you follow the instructions and it doesn't work. And so you have to talk to them and you have to say, there's the, and they're like, oh, yeah, no, that's different. I had one yesterday with pushing customers into a finance system, and there's a customer number. and it gets generated when you make a new customer. And I'm like, how do I do this via the API? And they say, oh, it will just work. I'm like, it doesn't. And then I find out that it's that thing when you send them the JSON, if customer number is present and is null, a customer number is not created because it thinks you are asking for null. But if customer number is not present, it will assign you a new one and give it back in the response, which sort of makes sense.
Yes.
Kind of, but it should also, like, for me, documentation is like, here's a list of all the weird shit we do that you're not going to expect. Because, if there's a post where you put a customer object that has a company name, if they've done their jobs remotely well, I can figure out what that's going to do.
Yeah.
And what I want to know from the docs is there anything weird going on here? Does company name have to be exactly 60 characters because that's the mainframe field length or something?
Yeah.
So, but yeah, and I think that the aspiration of microservices is teams wanting to be able to go, we don't need to coordinate in so much detail with the other teams in our organization because we can treat them like an external service. They've got a contract, they've got docs, we can just plug into them and do what we need. And for that to pay off, you need to be at the kind of scale where each one of your teams represents enough revenue in its own right that it's worth doing that.
Yeah.
And that's the thing that I think trips up a lot of people. And, we've all been, I did microservices. We had like 16 services on a team of 6 people because everyone was doing microservices. And then it turns out, they're not really microservices because they're talking to the same database. And, sometimes there's legitimate, a lot of
you can
folks like,
have a read service and a write service. I think that's
yeah. Yeah. There's all these patterns, CQRS is like, okay, we can do CQRS on this. And,
yes.
A fair amount of this is probably CV driven development, which is a powerful motivating force when it comes to architectural decisions.
Yes, it is.
But speaking of software doing weird and unexpected things, I'm going to share a screen again here because I want to show you something I found in .NET this week, which just made me go, that is really weird. And I want to show it here so that folks can take a look at it. So this is a chunk of C# code in Sharp Lab. And for the folks listening on the podcast, what it's basically doing is it's initializing a set of decimals, which are 0, M for money, which is the decimal suffix in .NET, 0.0M, 0.000M, and 0.0000000M. So they're all 0. They are all and this isn't like a floating point rounding error. Decimal is a fixed precision type.
Yeah.
So these values are all numerically equivalent. They are identical. They represent 0. But if I go over here and I console.writeline them using a format called G, .NET knows how many zeros there were after the decimal point. And I have no idea. Like, I want to take this apart. And I was going to do that today, but we're doing the stream at noon instead of 4 o'clock, which meant I didn't have the chunk of the afternoon that I was going to spend playing with this. But somewhere inside .NET, it remembers how many zeros.
I actually used the fact that it remembers.
No. Really? What problem
within
could
the last couple of
possibly
weeks?
solve?
So we are reading and writing XML.
Yes.
And the maximum precision that you can specify for it's either the weight or size. I think the weight of a package. So when you're talking to the Canada Post API, which uses it calls it a REST API, but it's all XML.
Yes.
And
which is valid.
It is absolutely valid, and all the media types are actually like vnd.cpc.shipment plus XML, and so that it's write, it's doing HTTP write, it's doing all that sort of stuff, and it does include links actually when you get things back. So it is, despite using XML instead of JSON, it is one of the most RESTful APIs I've ever used. But the maximum precision for weight in kilograms is 2 decimal places, and you will get a bad request if you specify more. And the maximum precision for length, width, and height is 1 decimal place. And we're writing decimals to XML using XML serializer.
Yeah.
And I spent a while trying to figure out if there was a way with attributes or something, I could tell the XML serializer to round to 2 decimal places, and there wasn't. And I thought, well, what if I use math.round and round that decimal to 2 decimal places, and then just let the and it does, it works.
Hmm.
So you're actually using math.round on the in-memory object so that the serializer will pick up that there are 2 decimal places and it will write it in the correct thing. So yes, this is
So if you
it's a
math
mad
around a
feature, and I
decimal and
don't
it
know why
comes
it's
out,
there, but it is useful. I've
so
actually used it. What are the chances?
if you math.round a decimal, so let's say 2.004, and round that to 2 decimal places, that gives you 2.004. No, it doesn't. The ad hoc example here can't convert double
Yeah,
the
no,
decimal.
if you
There.
do that, there you
Yeah.
go. And it does,
Wow.
it remembers it.
It does. So if you round 2.004 to 2 decimal places, you get 2.00, but the .00 stays there when you out.
Yes.
Okay.
Yeah.
Wow. So I discovered something that I thought was absolutely bizarre and could have no possible real world application. And you come back and go, oh, no, that's how we send package weights to Canada Post.
Yes,
Oh,
exactly.
that's lovely.
Yes. I love it when shit like that happens. Oh, that was a bad word. There goes the suitable for children thing.
I think
So,
they know
yes.
that word by now. I had a birthday party last year, and some friends of mine brought their kid along because they couldn't get a babysitter, and they pinged me and went, "Is it okay?" And I was like, "Yeah, it's fine, but it's an adult thing, so there will be booze and swearing, and they might learn some new words." And they're like, "I think they know all the words," and I said, "I bet they don't know the J word." And they come up to me at the party, they're like, "We spent a week trying to work out what the J word is." I'm like, "There's no J word. It's I just messing with you, you know." But
Oh, yes. I'm getting my new laptop.
what's your new laptop?
It's a Framework 16.
Oh,
It's very confusing because I pre-ordered it
yes.
back in August, I
Yeah.
think, whenever the pre-orders went live.
The
And I
pre-orders went
got
live a
myself
week after I bought my Framework 13, and I know that
and
because
when was that?
that was August last year.
Yeah, so I thought it was around then. I was loaded in August last year. I was working with Dave Whitney and making lots of lovely money per day, and the Framework laptop was kind of if they follow through and they succeed with it in 2-3 years time, when AMD release the Ryzen 6 or 7 or whatever it's going to be,
Yeah.
I can go to the Framework website and I can buy a new mainboard with that on it, and possibly buy new memory and SSDs if the standards have changed in the intervening time. And then if what they've done with the 13 is anything to go by, I can take the old main board, which is an AMD 7840U
Yeah.
processor, and I can put that in some kind of 3D printed case or something that I've ordered
They
off
sell
Amazon or
Frameworks
whatever.
sell a box which you can
And
put your
yeah,
old motherboard in to make a little computer that
make
can
a
sit
little
on the back of your
streaming
TV or
computer
something.
or yeah, just very, very
Yeah.
low powered unit. And so I want to sign up to that, and reducing e-waste and all that sort of thing. But so I put my pre-order in, I paid my £100, and then they said, we'll send you a laptop we'll send you an email when we're about to ship your laptop, and we'll let you modify your order and add on the Wi-Fi module that I think you forgot to add, because I've got the build it yourself version.
Yeah.
And then, yes, last night I'm just sitting on the sofa watching Fool Me Once on Netflix, and my phone goes ping, and Framework have taken 1,400 quid from my card. And yeah, I'm very close to being in between jobs at the moment, so I could have done without that.
Yeah, but you get a new laptop which you can use
But
to
I do
review
get a new
contract
laptop.
opportunities
Yes.
in
And
twice
then
as
I
much
can
clarity.
put Windows 11 on it, which is going to be fun.
So Windows 11, there is a tool called Rufus. Rufus is for making bootable USBs. And Rufus has an option now. If you use it to make a Windows 11 USB stick, it will say, do you want to deactivate cloud sign up? Do you want to enable local user account? Basically, do you want to strip out all the
Oh,
crap that Microsoft
yes.
marketing get a bonus every time they con someone into using it? So yeah, Rufus is fantastic and very, very good. And I'm going to drop a link to it in the chat here. Rufus Windows 11. There, rufus.ie, because all the best software is from Ireland today. And yeah, you use Rufus to make your boot CDs, and it will not only give you boot CDs, but you can actually preset a bunch of things that you then don't have to go into Windows and hack back out when you get to the other end. So absolutely, I did that when I got my framework last year and loved it. It was like, yay, somebody cares about usability in operating systems.
Yes.
So of course,
I mean,
framework they run Linux really well. So
yeah, but Linux doesn't run everything I need to run really well.
yeah.
That's a problem. If I think right at the moment, if Filmora
Yep.
did a Linux version, I could probably use Wine to run Office or use a VM or something. Could just about get away with it. But no, I will stick Windows on there. You actually, so I subscribe to Dave something on YouTube, who was a programmer on Windows, like way
Is
back
this
in the
Dave's
day.
Computer Garage
Dave's
thing?
Computer Garage.
Yeah.
And he was involved with Windows Pinball in some way, because Windows Pinball for the younger people was included in the box with Windows XP or Windows 2000,
I thought
possibly
it was
might
an
have even have been
NT4.
98. But yes, this
Yeah.
was, never mind Minesweeper. We got a version of Windows where they went, oh, look, pinball. It was one table. There are people who are ridiculously good at classic Windows pinball. But one of the things he did on his YouTube channel was dig out the source code for Windows Pinball, and he got it running on Windows 11. I don't know if it's downloadable anywhere, because obviously Microsoft might have something to say about that, but it is possible.
So Martin's so Renee just asked, can you re-add classic Windows Pinball? And Martin said, can you get Weezer's Buddy Holly music video? You can, because it is easy to find ISO images for the original Windows 95 retail release. Which is kind of in that gray area, like it's definitely not in the public domain, but also I don't think anybody cares what happens to it now. But bizarrely, Windows 95, I think I might have mentioned this on a previous episode, Windows 95 original will not install on any CPU faster than 200 megahertz, because it just won't.
Okay.
Because it won't. But somebody has built a tool that will patch the ISO and work around this limit. And it's little things like that make me love human beings so much, because somewhere out there's someone who both had this is not allowed. We should be able to run Windows 95 original retail release on a virtual machine, and the knowledge to patch an operating system ISO binary to make that happen. So
I have once in my life patched a Windows binary. And it was Windows 3.11 again, where the entire operating system was contained in a single file called win.com. And you would stick a DOS disk in your PC and it would boot up, and then you would type win and enter, and then it would go into the Windows operating system. So this one file, win.com, and you could open it up in a hex editor, and a hex editor would show all the hexadecimal digits in the main area of the screen. And then on the right-hand side, there was a column about 8 characters wide, where if the bytes represented text, it would show you what the text was. And so all the text, dialog boxes, titles, all these sorts of things in the whole of Windows was included in this win.com file, and you could find stuff, and you could find general protection fault in one place in this code, and you could edit it. And it turns out that general protection fault has one more character than Mongolian cluster. And so if you put an extra space in Mongolian cluster, then it aligns. And so we would go on to the secretary's machines, and we would edit win.com, and we would change general protection fault to Mongolian cluster. And then the next time they tried to exit Office 98 or whatever it was they were doing that caused some kind of memory egregious, heinous crime, and they would get a thing that popped up saying a Mongolian cluster has occurred, which has caused your application to terminate. And yeah, and we thought that was quite clever. So the idea of actually finding sort of meaningful executable bits of the binary and patching it to do something different is terrifying.
I once went into
so yeah, fair
Candy
played.
and changed the text on all the Windows screensavers in the window of the shop to free toothbrush with every keyboard, and then unplugged all the keyboards because the salespeople couldn't figure out how to plug them back in to change it back. And it was like that for about 2 or 3 days. But anyway, folks, that is about a wrap for this week, because I have to pack up my little magic box of tricks for recording meetups and go and get a new passport, which is very exciting because it's going to be blue, and it's going to request and require in the name of His Britannic Majesty the King.
His Britannic Majesty.
I know. Yeah, all rise for the national anthem. And then we're hosting a meetup. So any folks watching this live who are in London and want to come along tonight and watch Mark talk about how JavaScript happened, I've just remembered why I mentioned Seymour Cray right at the beginning of this.
Right at the beginning. Go on, then.
We were going to talk about how computers didn't have operating systems.
Yes.
And programming languages didn't exist. And yeah, I was just sort of going to say how almost every language that has been created is in some sense a reaction to the one before it. Because it's a lot of people going, oh, well, you know, assembler is machine code is fine, but it would be nice if the codes were easier to remember. Let's give them 3-letter acronyms. And then people going, oh, well, 3-letter acronyms are a little bit obscure. Maybe we could use loops and keywords like if and else. And then someone going, well, C is all very nice, but memory management is too hard. And then someone going, well, Java's all right, but checked exceptions are a stupid idea. Let's invent .NET. And you know, it's just sort of JavaScript is as you point out in the talk, everything in JavaScript came from somewhere, because there's very little in it which was genuinely original. And that's not, you know, I'm not saying it was derivative or ripped off from anywhere. It just, you know, Brendan Eich, who created JavaScript, knew a lot about the history of programming language design and the things which were likely to work for a relatively low-powered scripting language hosted inside a web browser. And yeah, I thought that was interesting. And so on that note,
under the, well, I'll tell you what, tune in next week. And I will recap some of the points from my
the talk will be on video, so that'll be up on the london.net YouTube channel tomorrow.
So just as one last fun fact for today's podcast, I will say that the only 2 programming languages ever created that were not a reaction to an existing programming language were Fortran and Lisp. And then everything else owes its existence, at least in some way, to one of those 2 languages, if not both.
A little bit like how the only science fiction fantasy that owes nothing to previous is The Lord of the Rings and Star Trek. And everything afterwards borrowed from them.
H.G. Wells and Jules Verne. But yes.
Anyway.
So yes, Renee, we will be back to the normal time next week.
Yes.
There's issues with Dylan's passport or something.
No, it'll be fine.
But yes, 4 o'clock next week.
The problem with this week is I forgot to put this in my calendar. And so when I looked to see when I was available to go to the passport office, I was like, Thursday afternoon's wide open. I am stupid. It's not in my calendar. It does not exist. I cannot function on biology alone. I need the data. So anyway, yes, next week, back to the usual time, 4 o'clock UK time. Have a lovely week, folks. And we'll see you then.
See you next time. Bye.